Please welcome to the stage David Brebner, founder and CEO of Umajin.
Hello everyone. So are we becoming cyborgs? With our smartphones, we have positive and negative aspects. We can have access to maps and information instantly. We can complete our business tasks much faster and much more efficiently. I guess the challenge is there's also dopamine loops and problems with social media. People are spending a lot of time looking at their devices than perhaps engaging in the real world. So are we experiencing the real world or capturing the real world? Maybe we're reviewing it later. I'm not going to talk about some of the negatives. I'm going to focus on the augmentation aspect. So I'm going to talk about, hopefully, how we can become better cyborgs. So Umajin is a platform we've created to allow you to build applications that bring together technologies to enhance the human experience and to make it easier for humans to create those experiences. And we find that those experiences tend to have, if you're doing anything complicated, there's CAD data, 3D models, simulations, AI, and then you're trying to apply it to human processes. So it's humans in the end that are consuming these experiences. They're talking together and making decisions. So that's sets the scene. So there's three key cybernetic trends where hundreds of billions of dollars have been spent. The first is this incredible improvement in image sensor technology. So in this case, I'm going to look at our software, which sits on top, and did you know that butterfly wings have scales? And what's interesting is if you go in and scan those scales using our process, so we can analyze them in 3 dimensions, so those colors tell you the direction of the surface, and then we go in and look at the absorption, you can see the nano ridges that make up those scales. So you can't see those with your human eye, but we can make them visible. AI and compute. All of our cell phones are driving this. So today's smartphone is yesterday's supercomputer. So they're just the continual grind, not just Moore's Law, but all the specialized compute, the improved algorithms. This is my hometown in Palmerston North in New Zealand. We can take 4K video in real time and segment all the people, the vehicles, all of the stuff that's going on that scene. That's science fiction 5 years ago. And then the third trend is augmented reality. Now, that's a very challenging space. There's a lot of money being poured into it, and it hasn't really worked out for everyone yet. But 70% of our brain, one way or the other, is processing information from our visual field. So it is going to be a great way of interfacing with a computer. These are the new NTT AR glasses coming out this year. These are the Meta Orion glasses, which were demonstrated, not yet available. And this is the Meta Quest 3. There's a lot of other products that have been in the market, but we're really excited about what this can provide. And the use case is we've got an inspection system for vehicles. It's detecting these flaws, but you need to be able to visualize them. So you just put on the glasses and you can see them. So now I'm going to talk about some specific use cases. So these are the cybernetic superpowers that we can enable. The first one is inspecting batteries. So this is for EV manufacturing. The challenge is these batteries are very shiny. They have different materials. They have different properties. What we're actually doing is a technique called photon tracing. So there's a series of lights that move around the surface. We take the image from above, and the only place that a photon could arrive at the camera is from that point light source, the only place in the universe. So as a result, we can compute material properties. This is the shininess, and then this is the normal map. So this is the surface 3D angles. And if we zoom right in, we can pick up this defect in the insulator. So that's just really, really hard to do as a human. You can do it easily now. This is a motherboard, so it has all of the normal shadows and reflections and complexity that we see as a human when we look at an image. And what we're going to do is going to deconvolve that. So this is the shininess. So all those numbers have disappeared because they are matte. And then this is the normal map. Once again, that 3D shape. And what's amazing about this motherboard is there's a silk screen with printing on it. If we zoom in, you can see the edges of the ink, which is only 20 microns thick. And we can see how that ink folds over the edge of a copper trace on the motherboard. All right, we're going to look at refraction. So that's bending of light through a subject. So in this case, we're looking for scratches on glass. The problem is there's condensation on the glass. Everyone can see there's scratches now. And amazingly, you can see the drop appearing just now. That's the drop you can see in the background. So that's a change in refraction over its surface. So now we're going to look at the very small. So this is a 19,000 times zoom. I'm going to zoom into a millimeter on a stainless steel ruler. That's the 7 and 8 millimeter mark. These are the 2 millimeter markings just above. So physically, on the 6,900 pixel wide stage, every one of those pixels you're seeing is 220 nanometers blown up to this scale. We can see the surface of the crystalline cold rolled stainless steel, and we can see where it's thermally changed its texture as it's recrystallized. So we can perceive molecular level items just using light. This is bovine IVF. I live in New Zealand. We have more sheep and cow than humans. We don't use IVF very much, despite it being really useful. It's very time-consuming and difficult. So on this image just here, we can actually see a sperm that's been trapped in the outside of the egg, whereas that sperm in there has made it in, and that's fertilizing that cattle egg. This is down to 220 nanometers per pixel again, so we can literally study the morphology of these objectively and in a much more scalable manner. So once again, giving us superpowers. This is a really interesting example. So this is monitoring blood. So when you take blood, traditionally you would go through a process of testing that blood. You'd put it in you'd spin it around to separate the blood into its components. You'd mix it with a reagent. Here we can literally look at what the blood cells are doing in real time and see how they change shape or react to the reagents. All right, now we're going to see the invisible. So this is acetone in a bottle, and you can't see anything until now. So this is the change in refraction or the change in density of the air where there's a little bit of acetone in the air. This can also detect shock waves on the front of a plane wing or changes in heat, and if you're looking at thermal expansion and you're trying to measure the flow of fluid in a gas in a volume. And hey, we're cyborgs. We're at least part human, so we can appreciate art. So this is a really interesting example. This is a piece of an oil painting. And over here is the diffuse image. This is just the colors, and this is the 3D shape. So it's been extracted, real data extracted from the image. So what's interesting about these images behind me is these don't exist in the real world. These have all been generated in a computer. So when you put on a VR or an AR headset, instead of seeing paintings that look flat and boring, we can relight the scene exactly as that painting was in real life. So it captures the specularity of different paints and their shape and color. And this is an example of manufacturing training. So in this case, it's really great if you're a manufacturer because you have lots of CAD data. So we can grab that CAD data, bring it into the Umajin platform, position it with your assets. And then, in this case, it's VR, but you can also do this in AR. So these people are being tracked, their hands are being tracked. They're using hand gestures to talk to each other, which you have to do in a loud factory. They're going through a training process and doing something that might be difficult or expensive. And that's the best kind of cybernetic augmentation because you are using digital processes to enhance your performance and increase the quality and safety of the work that you're doing. So thank you very much. Hopefully it gives you a taste of some of the cybernetic opportunities in front of us.